We covered fan pressure and airflow characteristics in the first session. We will use this in this chapter to learn how multiple CRACs or air handlers interact. We will analyze how CRACs with variable frequency drives or VFDs can offer power efficiency that a non-VFD CRAC cannot. Consider a data center with multiple rows of server racks cooled by two CRACs. For simplicity of analysis, we will place them next to each other. We are interested in the airflow that is discharged at the tile to cool a certain server rack. The heat load of the rack determines the airflow required at the rack. The underfloor airflow path between the CRAC and the perforated tile has an impedance Z. This impedance and the CRAC airflow characteristics are critical factors that determine the amount of airflow that reaches the tile. A CRAC fan without VFD operates at a constant full speed. It cannot be speed controlled. When one such CRAC is in operation, its pressure airflow fan curve is as shown. By superimposing the impedance curve of the airflow path from CRAC to the perforated tile, we can estimate the airflow Q1 available at the tile. When the second identical CRAC is turned on, the effective fan curve shows doubling of airflow capacity without any change in pressure capacity. This is similar to connecting two batteries in parallel. Their combined current capacity is double, but the voltage still remains the same. The airflow discharge Q2 with two CRACs is higher than Q1. Even though the airflow capacity of the two CRACs is twice that of a single one, the airflow reaching the perforated tile does not double with two CRACs. If the airflow required to cool a rack is less than Q2 but more than Q1, then both CRACs need to be operated and the extra airflow will be wasted. The airflow at the maximum fan operation with VFD looks identical to that without VFDs. The difference with VFD is that the fan curve can be varied by changing the fan speed. Unlike in the previous case with non-VFD fans, here both pressure and airflow capacity can be changed. At the maximum fan speed, the airflow discharge will be the same for fans with or without VFD. The airflow can be modulated to match the need by varying the fan speed. The VFD-based fan can deliver exactly the required amount of airflow by varying the fan speed. However, in a data center, the airflow demand at different racks are different. Since the only parameter that can be changed is the fan speed, it is impossible to control airflow at multiple racks independently and simultaneously. So the fan speed control is done around the worst case rack. That means several other racks are still overcooled and overall cooling efficiency is not high as attainable. Heat generated by a rack determines the required airflow. The airflow and underfloor impedance determine the fan pressure, which in turn decides the fan speed. So for a given heat load and an underfloor impedance, the minimum fan speed is predetermined. Since a server heat load is a given, the primary way to change the cooling efficiency of a given data center is to reduce the underfloor impedance. We will cover that in the next chapter. Thank you.